All right, guys, so let's get this going. All right, so for the questions 1 through 12, we are going to be using this entire graph. Everything we need comes from this graph, okay? So let's first talk about the graph. So this graph here, this zigzag looking line, is actually called the function f. All right, so that's what we call this graph, just the name of it. So remember I told you a function is just input-output table that we can turn into a graph. We could turn it into an equation. It's just input-output. Now let's look at the graph. Our horizontal line in this case is called the x-axis. But what I want you to understand is the x-axis represents our input axis. These are the numbers we can plug in so that we can get an output, okay? If we look at the y-axis, it's no longer called the y-axis because we're using function notation, but this usually was the y-axis, and this is our output axis. Okay, so let me give you an idea of what I'm talking about. I want you to focus in on this point here. Okay, if I wrote down the point, and hopefully you remember from Im2 how to write down this point, we would say we're going from the origin, we're over 3. So if you notice, over 3 is on my input axis, my x-axis. So I would put the number 3 here. Okay? Then, once we go over 3, we are going down. So down -1, -2, and that gives me this point. So we are on my output axis. So that is my -2. So essentially what we have here is our input and our output for our function. Okay? And if we could understand that a graph is just the points in input-output form, then it makes all this 1 through 12 a little bit easier to understand. Okay? So remember, your input is your x. And your output usually is your y, but when we're doing function notation, we use this guy to represent our output. F parentheses x. Okay? So let's check this out. Okay. Let's jump to number 1. So number 1 says, I want to find the function's output. Remember, this represents output if my input is 3. So this is my input. So if I can figure out my input, what is my f equal to, or my output equal to? Okay, so let's look at the graph. So what we're looking for is, we're looking on the input line and we're looking for 3. So we look for +3. 1, 2. Here's my input line. Okay. So I'm going to draw a vertical line here real quick. So that's my input line of 3. So what I'm basically looking for, on my input of 3, does it cross the graph? And it actually does. It crosses the graph here at input of 3. So if my input of 3 is, what is my output? And we actually figured that out already. My output is going to be -2. My input's 3, my output's -2. So that means my output here is -2. Okay, it's all about input, output. If you learn to read it that way, it makes it a lot easier. All right, let's do number 2, just to make sure. F of 0. So again, we're using the function f, okay? And we're inputting 0. So here's my input. I'm going to have an input of 0, so I'm going to look on the input line. Here's the input of 0. So now looking at this vertical line at 0, because this is what this represents, do I have the graph crossing it? So I look, it crosses right here. So what is that input output? So I know that input is 0. What's the output? It's 1, 2, 3, 4. Input, output. Okay? So that means my output is 4. All right. Number 3, y-intercept. Where does my graph cross the y line? Okay, where does my graph cross the y line? Remember, your f of x is just your y line. So it's basically asking, where does my graph cross the output line? It crosses it at this point. Remember, when we talk about y-intercept, we always use a point to represent it. So in this case, I have one y-intercept, and it's 0, 4. Okay? So let's jump. We're going to skip 4 for now. I want to go to 5. We'll come back to 4, I promise, because I think 5 is a little easier to understand. And then we'll go from there. All right? So let me erase my work on the graph real quick to clean this up so you don't get super confused. Okay? All right. So number 5, we are asking for the range of f of x. Remember, f of x is the name of my function. What the range is, if you recall, your range is just your output values. Okay? So your range is your output values. So let's look at our graph. To figure out our output values, we're going to look at the output line. Okay? And what we want to do is we want to figure out what is the lowest or the smallest output I can possibly have. So let's look at the graph. We're looking at the output line. And I'm going to draw a horizontal line here. Okay? This line that I just drew in represents when my graph has an output of -6. If you look, my graph never crosses this line. So that means I do not have an output of -6. I'll draw in another line. This represents an output of -5. If you look, my graph does not have an output of -5. I don't have any part of the graph that crosses this line. The lowest number that my graph actually crosses on the output line is -4. So what that means is the lowest output number I have, because look at it, actually crosses twice. The lowest output number I have is -4. So this is how we're going to write the range. We first want to write the lowest output number, which is, in this case, -4. Okay? And then we're going to write the highest output number. But real quick, before we move on, if we look at output -4, which is this line here, do I actually have dots on that line from the graph? And the answer is yes, you have 2 dots. So when that happens, instead of using parentheses, we use a bracket. Okay? So we want to get comfortable with this. Like I said, you're not going to learn this right away. It takes time. So this is my lowest output. So I'll write that in, lowest output. Okay, and you saw how I did. I did horizontal lines for the lowest possible number. The smallest number was -4. Now I'm going to do the opposite. I want to know how tall does my graph get? Okay, and how tall does it get on my output line? So if you look, the tallest on my output line would be here. +4. Okay, so this is my highest output value. So this is going to be positive 4. And then I got to ask myself, does my graph actually have a dot or touch positive 4? And it does. It touches it right here. Okay? So that means instead of parentheses, we're going to use a bracket. That's what that means. Okay? This is domain and range using interval notation. So this is the highest output. Okay? The other way you got to get used to writing it is set notation. And set notation does the same thing. We start with the lowest output, which we know is negative 4. And then our highest output, which we know is positive 4. And since we're talking about output, remember this guy represents our output. So we're going to put him in the middle. And then we put the alligator mouths. Because negative 4 is actually touching some dots, we put a line underneath the alligator mouth. Because the line positive 4 is touching a dot, we put a line under this alligator mouth. Okay? And this is a second way of doing the range. This is called set notation. Interval notation, set notation, they mean exactly the same thing. So that is our range. Your range is your output values. Let's jump over to our domain, number 11. Okay, number 11. Okay, number 11 is very similar to the range. But now, instead of output values, our domain, if you remember, is I want to know all my input values. Okay? So let's look. Our input values come from our X line. So we want to know what is the lowest, so we're looking at the negative side, what is the lowest input value that actually crosses my graph. So if you look, if I said negative 10 is an input value, which it is it part of my graph? And the answer is no. How about negative 8? Negative 8, none of my graph touches it. So negative 8 is not an input value. My input value actually starts here. And that is negative 7. So my lowest input value that belongs to my graph is negative 7. So I'm going to put that first. Negative 7. And then we have to ask ourselves, are we using parentheses, which means my graph does not touch this point? Or do we have a point on my negative 7 line? And since we have a point, we actually put a bracket. Okay? So this is my lowest input. Okay? Now we're going to go to my highest input. So we're here. What is the last input I have that's the highest number? And you look, it's going to be 8. Okay? And since 8 touches my graph, again, the 8 line, the vertical 8 line has a point on it. That means it has a bracket. So my highest input is 8 with the bracket. And this is my highest input value. Okay, that is set notation. If I'm doing that's interval notation. If I'm doing set notation, we set it up like this: negative 7, positive 8. Because we're dealing with input values, we check our input value is represented by the X line. So we're going to call X in the middle. And we do our alligator mouse with a line underneath because we have brackets. Okay? So again, get comfortable with both of those. All right. So that's how you do input, output, domain, range using the different notation. All right. Let's go and jump to number 4. Okay? So number 4 is we want to know when my graph, remember this represents my graph and also my output. We want to know when is this graph decreasing. So what does that mean? It means when is this graph going down, okay? So how do I check that? What we want to do is look at the graph starting at the left, and as we move to the right, our graph, as you can see, goes up and down as we move to the right, okay? What we want to know is when does this graph go down? So what I tell my students to do is I want you to put vertical lines, okay, on the input, just like we did when we did domain, of where my graph starts, when it changes directions, okay, and we're just going to put vertical lines there. So my graph starts on my input at, as we said, -7. So I'm going to put a vertical line here. This is where my graph starts, okay? Our next vertical line is going to go when my graph changes direction. So right now my graph is what is called constant. It's not going up, it's not increasing or decreasing. It's constant. So I'm going to put another vertical line when my graph changes direction. So it's constant, and boom, right here, I'm going to put a vertical line here because it's changing directions. It's now going up or increasing. So let me write this in. This is constant. It was not going up or down. Okay. Now we're going increasing up, and then we change directions here at this vertical line, which is actually 0. So we're changing directions there. So let me put an arrow in here. We were increasing here. Okay. Now we change directions, and now we are decreasing. That's why I put a vertical line, because we're switching directions. We're decreasing. And then we stop decreasing here. So I'm going to put a vertical line there. Maybe. My vertical lines are horrible right now. Come on, Fernandez. There we go. That's the best I could do. Okay, so that is my vertical line where I decrease, or where I stop decreasing. So now that means, I'm going to put an arrow here, it means we are going down in this section, but we're not done. So now we're here, and now we're constant, and then my graph ends. So I'm going to put a vertical line where it ends. Okay, so let's go through it. This is how you would read this. From -7 to -2, I am constant. From -7 to -2, I am constant. From -2 to 0, I am increasing. From 0 to 3, I am decreasing. From 3 to 8, I am constant again. Okay, so what number 4 wants to know is, in what section am I decreasing? So if you look, I'm going to highlight that for you. The section where I'm decreasing is this section. And then we look at our vertical lines. When did this decrease start? It started on 0, always using the input values. Started on 0 and it ended at 3. So we use this. Starts at 0, ended at 3. That is interval notation. If I was doing set notation, it would be 0, 3. Remember, using the input values as our measurement, the x values, it would look like this. And the reason I don't have brackets here, or I don't have a line underneath, is because at 0, that's when I started decreasing. I'm actually not decreasing at 0. Same thing here. I stopped decreasing at 3. So I'm not actually decreasing at 3. That's why we don't put a little line underneath here. I'm not decreasing at 0 or 3. Okay? So that is how we do decreasing. So let's jump to 7. Where is f of x increasing? So same idea. So if we look, I want to know where is my graph going up, and we sectioned it off, so it should be very easy to see. So we're here, from here to here is constant, from here to here it's going up. So here is my increase. I haven't put an arrow there for you. So when does my increase start? Look at your vertical lines. It starts at -2 and ends at 0. We're always using the input to do our measurements. -2 to 0. So it's increasing from -2 until we get to 0. Using parentheses in this case. -2 to 0. And that's set notation. Okay? Cool. Number 8, I'll let you do. Okay? There's going to be 2 answers for number 8. When is my graph constant? Okay? If you want to do it, and then check it. But you do that on your own time. We're going to jump into this, negative. Okay? When is my graph negative? Okay? So what that means is, let's erase all this stuff here. And what I want to know is, when is my outputs negative? So remember, this guy here, this entire guy represents your graph, but he also represents output. How do I know he represents output? Because we simply have to look at our line here. Our vertical line's our output line, and it's named f of x. So we want to know, when is our outputs negative? So in other words, the only time our output is negative is when I have a point or part of the graph that's below here. So if you look, my outputs are all negative from here down. See how they're -2, -4, -6. So we want to know is, when is my output or my graph, what I like to call, below the x-axis or underwater? When is my graph underwater? So what we have to do is use our x to measure when my graph is below water. For example, is my graph below water at -10? And the answer is no, because there is no graph at -10. The first time it's below water is at -7. So it's below water at -7. So that's what I'm going to put here. It is below water, again, because I have a dot there, at -7. That's the first time it's below water. Okay, so let's put a line, a vertical line, when it stops being below water. So still below water, still below water, still below water, and then bam. Right here, it's no longer negative. It's no longer below water. Okay, so what number is that on the x-axis? That's going to be -1. It's no longer below water. Okay? Is that the only time? So now we're above water, above water, above water, and then boom, again, we go below water at -2. My outputs are negative at, starting at, not -2, but +2. When does it stop being below water? It actually doesn't stop being below water, but it stops existing at 8. So the next time it's below water is from 2 to 8. So let's put that in. Okay? And this is interval notation. Okay? If you want to write it in set notation, it would look like this. -7, -1, -2 and 8. I keep putting -2. It's actually +2. Sorry. Okay. So again, these mean the same thing here. All right. Let's do one more. Okay. Number 12. On number 12, I want to know, remember, this is my input. The X represents my input. And this guy is my output. So it says, when is my output -3? Okay, so that means looking at the output line, I want to go to -3, and I'm going to draw a horizontal line here. Okay, let's make this a little thicker. So at -3 on the output, let's do a horizontal line. Okay, so that is -3 for my output. So I got to check, does my output cross my graph? And the answer is yes, it crosses here. So I want to know, we know that my output's -3 here. What is my input? So we go here. So if you look, my input would be, looking at the input line, would be around -2. Okay, I'm estimating here because it's not that accurate, but my input would be -2. Okay, so my X value, which represents my input, would be X equals -2. Okay guys, I'll let you do the rest. I pretty much covered all the topics there. I know it's quite a bit of stuff to handle, but I'm going to let you go ahead and do the rest. Check it out, turn it in today, and then get it done, okay? I'm going to give you your checkout code now. Once you check in with DOOR, D-O-O-R, then you are free to go. Stay on if you need extra help.